All right, so let's take a look at how to implement the following data model. Here we have a base class user that is being inherited or specialized by two other derived classes, the faculty and the student. And we have the student that has a one-to-many relationship with a couple more classes, such as course and section. And we also have a many-to-many mapping between students and sections with a association called enrollment. Right? So first we can start by implementing a just a regular POJO, plain old Java object that captures the user, the base class user. Right? So if we grab that and then in our project, we could create a data model here under a package, say models, right? So we'll create here under models. We'll create a base class user, and under here we can then add all the primitive data types that we might want to model here. So we have just ID, username, password, first name, and last name, plus many other fields that might not be just these primitive data types. We'll add also any accessors, setters and getters, perhaps from source. Just select all of them and add them. And we're only adding ID here only because we know we're going to be persistent this to the database, right? Otherwise, we would not be even bothering with ID. If this were a truly POJO, the object itself would have its own unique identifier, right? The address of where it lives in RAM has its unique identifier. But because we know that we're going to be mapping this to a relational database, we are adding this arbitrary unique identifier. Okay. Also notice that we haven't added any constructor, so we have the default constructor. So with the default constructor and all these setters and getters, this meets all the requirements for this to be a Java bean, right? Which is one of the minimum requirements for this to be an entity, to be mapped to a relational database. Right? It has to be a Java bean. If you remember, if you add any other constructors, right, other than the default constructor, remember that you'll need to add specifically the default constructor, the no argument constructor, right? Because you get it for free unless you override it. All right, so we'll declare this using the entity annotation, and the entity annotation declares this as a JPA entity that will be mapped to a relational database, right? And by default, it will be mapped to the same name as the class. That's by default. Although you can override, and you can override it and say, no, I'd rather map it to some other table. Okay, meaning I might want to have a user the name of my class unaffected by the name of some table that might have an obscure name. It might have acronyms in there, might have prefixes or postfixes inside of the relational database, and I would not want to litter my clean Java object class data model based off some poor naming convention that they might have used in the relational database. Okay, but here we're using the default. The table name will be the same name as our class. Okay. All right. Also, we're going to declare this to be our primitive data type. I mean, our primary key by using the ID enumeration. All right. So enumeration is also part of the JavaX.persistence. Be careful not to be adding any other annotations, right? And it's the ones that are under the JavaX package, JavaX.persistence package. That's what the JPA library API is. Right? All right, so that's enough to declare this as a primary key. But if we stop here, we would be responsible for managing that primary key. We would need to create a unique identifier once before we insert in the database. Instead, we're going to delegate that to the database. We're going to say, I don't want to handle the primary key. Instead, I want you to generate it for me. Generated value, right? And the generated value has several strategies, right, of how is it that we want the database to generate these for us, right? It depends on different strategies that different vendors might have, right? So if you're using Oracle, for instance, Oracle typically what it does is that it generates a sequence, a large number of unique identifiers from which you can then draw the next identifier from that sequence. If you are in MySQL, typically you can declare the primary key to be auto increment, and it'll just increment, one at a time, or 10 at a time, or skip as many as you want, and you can configure that all from within Java. So to do that, we can provide a strategy of which there are several, and I'm going to be using the identity strategy. The identity strategy will mean that it will use auto increment in auto increment in MySQL, and that's it. That's all we need to do. If we compile this and do Maven clean install, or start the server and build this, let's see where to go. If we go to the entry point class, which is, I believe, this one. Why is my font so small now? Okay. If we run this as a Java application and we go back to our database, that's not it. Which one was it? Oh, this one. Okay, notice that the user table has been added. Right? JPA has created how did my font go so small? Really? Jeez, I don't know how to make it bigger. Plus? No? All right, whatever. Anyway, so we can see that the schema is what we would expect. We can go into columns. Notice the naming convention, replacing the underscores for the capitalization instead. We have password IDs, and we can take a look at the take a look at the schema. We can send to a SQL editor. We can look at the create command that was used to create this. Notice that ID was declared as an auto increment and also as a primary key, and everything else was given a default size of 255. That also can be configured from within Java. Okay. All right, so there we go. So we have our first base class. How do we interact with it? How do we talk to the database? So to talk to the database, we need to create what is called a repository, right? A repository is based off of what JPA calls the entity manager. So JPA, typically to talk to a database, instantiates what is called as an entity manager. An entity manager allows you to, is your entry point to the communication with the database, right? It gives you all those generic functions, right, that you would expect, right, such as find all, create, find by ID, update, delete, right? All these generic functions that are parameterized, right? They're configured based off of the class that you're interacting with, right? In this case, it's the user, right? So you need to be able to parameterize and say, hey, we want to talk to users. We want to be able to insert, update, select, delete users, right? So that's what JPA does, right? It provides the entity manager. What Spring Boot does is that it wraps around the entity manager an additional abstraction called the repository, right? And the repository takes care of some lifecycle methods that we would otherwise have to handle ourselves. For instance, typically if we use the low-level JPA entity manager, we would have it every time we talk to a database, we would have to start a transaction, do all our work, and then commit the transaction. All right. So there's some quirky things about the entity manager that the Spring Boot framework just takes care of us, right? So we don't have to explicitly start the transaction unless we want to. It will automatically commit the transactions so that everything gets written to a database. So we're going to be using this higher level abstraction of the repository. Okay. So let's create a repository. So typically there will be a repository per entity that we're going to be talking to, right? So if there's a user or a faculty or a course or an enrollment or a section, there will be a repository for every single entity. And each one will implement the CRUD operations for that particular entity. Each entity we want to be able to CRUD, right? I want to be able to create a new section, create a new user, create a new faculty, create a new course, right? I want to be able to update a faculty, update a course, update a section. So they all have CRUD operations, yes? So each one will have its own repository. So let's create a repository. Let's see, under here, we're going to create another class, and so I'll put it also under package com.jga repositories, right? And we'll call this the user repository. Okay. Another thing about naming conventions. Notice that I've been adding to my packages all com.jga or whatever, right? You can choose whatever naming convention you want, but I am being consistent, right? And in particular, I am using as a root of my package name com.jga. You see that, right? That's based off of the package where my main class is. See my main here? Okay, that's very important. Right? So what happens is that when the Spring Boot application starts up, right? It looks at the base package name, in this case com.jga, and based off of that, it knows that all the classes under that package are of interest. Okay? In particular, for instance, is that these entities over here, this entity is declared under the base package, com.jga, and then further down onto models, yes? But what it does is that it says, I will only care about the classes that are under here. If you declare any other classes outside of com.jga, I'm not going to pay attention to them. You can compile them, you can use them, but I'm not going to work my magic. Right? In particular, I am not going to become aware that this is an entity that needs to be mapped to some database. Okay? Instead, you're going to have to explicitly register it with me. Right? And that's painful. Right? You would have to go into your main and explicitly register the classes as an entity. It says, this is an entity that I want you to keep track of. Right? That I want you to map. Or you would have to declare them in some XML under the resources. You have to say, hey, there are these resources that I want you to map to the database. Right? So if you want to skip over that pain of having to declare entities that you want to be mapped, it's easy. You just follow the naming convention. You declare it under the package name, the base package name. Make sense? Right, so that the Spring Boot framework knows that under there you have several managed objects, including the user. All right, great. So the repository. So there's nothing in my repository, and my default font is awful. All right, so what do we want here? First of all, this is going to be an interface that is going to declare all my CRUD operations, right? Find all users, find a user by ID, create a brand new user, update a user, delete a user. So it's going to declare all my CRUD operations. But because I'm lazy, instead, I'm going to declare this as an interface, and I'm just going to extend an interface that already does this, that already implements all these base CRUD boilerplate, they all look the same, CRUD operations, right? So I'm going to extend CRUD, and I can't find it. What is it? Extends. Oh, there it is. CRUD repository. There we go. CRUD repository, and it's part of the Spring framework, right? That that implements all the JPA interfaces. So notice that this takes the CRUD repository, will implement all the CRUD operations for me, but I need to configure it. What is it that you want to CRUD? Right? Well, I want to CRUD users. All right? And the user is the user that I just declared under COM.jGA models. There it is. And it wants to know the type of the primary key. It wants to know, how do I uniquely identify these users from the database? Right? And in this case, these are just plain an integer. And it needs to be the class type, not the primitive data type. Right? It needs to be the wrapper class. Right? And that's it. This implements all the base CRUD operations. Right? It doesn't implement any custom finder methods. So it allows me to find all of them. It allows me to find one by ID. Right? But if I want to find it by something else, by username or by some predicate, right? By salary, by date of birth, or by how long have they been in the company, blah blah blah. I would need to implement my own, right? And we'll take a look at how to do that in a bit. All right, we got our repository. Excellent. So next, we need to be able to actually start using this. Well, first of all, we verified that the schema was generated successfully. Let's see how we can start interacting with this. All right, let's see how we interact, and that's a perfect segue onto being able to access things through a RESTful service. All right, we have the minimum we need for JPA. Let's look at what we need minimum to be able to access this through a RESTful API. And we'll do that next.